This is AP Calculus, Unit 1, Lesson 6. So today, oh, that's not what I wanted to go to. We are talking about average rate of change. So this is our first time that we're hitting standard D, rates of change. So I should just circle it for the notes. All right, so we have this very long word problem about my trip, and this was from last year, of course. So I leave at 7 o'clock now. Mr. Sindel's daily drive, I leave my house at 6:20 a.m., and I'm going to call that time 0. Every weekday morning. The number of miles I drove or have driven are modeled by a function, and I'm going to give you the values from that function. And this just means from 0 to 60 minutes. That's what this function is defined around for t. Values of dt, which is a distance, at various times are shown below. We're going to graph these to the best of our ability. My graph is kind of small here. You probably want your y-axis to be bigger, but if you already drew it kind of like mine, that is completely fine. So let's first mark out these time spots. So 0 is obviously going to be this y-axis. The next spot is going to be 5. We know that out here we want to be at about 60. That is poor penmanship. There we go, 60. So we can kind of scale everything. We know that halfway is going to be about 30, which is one of the times that we're given. We know about 2/3 of the way between 0 and 30 is going to be, maybe it's a little bit right here. That's going to be 20. And then 5 is going to be really close. It's going to be right here. We are also given 55, which is really close to 60. So now we have all the times on our x-axis, and we should label our x-axis just to make sure that we have everything that we need. Time in minutes. Our little review from Algebra 1, labeling the axes, making sure we have a title. The title is technically right there, I guess. Our y-axis. What is the title that we're going to give this axis?
Distance.
Distance, yep. And I ran out of room. Distance. Does it say the units that we have in our problem?
It says miles.
Miles, perfect. Distance in miles. So again, we're going to mark up this y-axis. So the biggest distance we have is 50, so I'm going to make 50 at the very top. We don't, oh yeah, halfway is 25, so halfway right here is 25. And then we can kind of scale everything accordingly. So right here is about 45. And then we have 20 right below 25. And 6 is going to be really close to the bottom. It's going to be right about here. That's going to be 6. All right, now we have all of the x and y values. We just need to make the points and connect them eventually. But for right now, let's just make the points, and then we'll talk about what we're going to do with them in a sec. So 0, 0 needs to be the first point, and I forgot to do that, of course. 5, 6, then 20, 20 vision. 30, 25. 55, 45. And 60, 50. All right, so what we could do, and I don't want you to do this right now, but what we could do is connect each of these lines individually with lines that would look like this. Line here, line here. The trouble with doing this is, I mean, it tells us an approximate rate of change between the points, but we don't know what's actually happening. Maybe I actually went really far and then turned around and something weird happened in between those points. We don't know what's happening in between those points, but what we can say is that I started at 0 and I ended at time 60 at 50 miles. I can say what my average speed was, my average speed. So just looking at the table without drawing on it, can anyone tell me how to find, not necessarily what it is, but how to find the average speed?
It's going to be the in miles per hour. Well, I guess it's just 60. It's just going to be the number of miles you traveled in the entire time. Is that 60 minutes? So it's 50 miles an hour.
Yeah, it's going to be 50 miles per hour. Because this is 60 minutes, so that's 1 hour. Yeah, perfect. Yeah, and then graphically, do we know what that looks like? So that's the logic behind it. And I am going to make that more explicit in the next slide. But yeah, the logic is I went from 0 to 50, so I went 50 miles, and I did that in 0 to 60 minutes, so I did 50 miles in 60 minutes, or 50 miles in 1 hour, so my average rate was 50 miles per hour. What does that look like on a graph? Any ideas?
You mean like the equation?
No, so that's the equation, and that's kind of, you gave me the words for the equation almost. On a graph, this is what it looks like. So I'm going to maybe do this. This is better. So in red, and if you have colors at home, like this is my favorite. If you have a colored pen with 4 different colors, it's really nice for calculus because I'm going to color code the heck out of all of our stuff. If you don't like pen though, maybe you can get erasable pen and still have colors. I have a few examples here for erasable colored pens. It does make the notes better, but if you just want
use a regular pen, maybe I should get a colored one.
yeah, so if you want to get a few different colors, that would be nice.
Those color ones that click are fatter.
They are a little bit fatter, but they're still really nice to have all your pens with you at the same time. What I'm going to do is, in red, I'm going to circle my start and end points. Those are the 2 points that I care about. I don't really care what happens in between, because I could have gone all the way up here, all the way down here. My average rate is just judged by my start and my end. And finally, I'm going to connect those 2 points with one solid red line. And if you want to grab a ruler, you can. They're up at the front. It does make for nice notes. I have technology on my side.
A ruler's technology too, though.
That is true. I have newer technology on my side, I should say. All right, why did I draw a line between those 2 points? Any ideas?
That's where you would theoretically be at any given time
If
the average rate of change was followed.
Yeah, so if I was actually doing a constant speed and I ignore the table values, that would be where I should be for each time value. And what does the slope here represent? It's something that we already mentioned before.
Average speed.
There it is, yeah, it's the average speed. The slope of this line is my average speed. So instead of using the word speed, in calculus we use the word rate. So I'm going to say average rate. And I'm going to also write this down, that the slope of this line is equal to the average rate. Average rate. And I got that just from looking at 2 points, the start and the end. Those are the only 2 points that I cared about. So far, so good. All right, so technically we started average rate right here because I started labeling it. So I'm going to actually come back to the left-hand side and say this is average rate. Maybe I should write it out. Average rate. So on the next slide, I want to kind of define formally what Ben was talking about with average rate. This is average rate continued. So let's give this one a giant star. This needs to be in our summary. Average rate, this is how you calculate it without a graph, is simply, and I'm going to give you a bunch of different definitions. You can write down your favorite one. It's just distance over time. It's the total distance over the total time. And some people like to say, okay, well, that's the total rise. I cannot spell total rise over the total run. That sounds like slope to us. And the best informal definition I have is the end minus the start for the distance. All of that divided by the end minus the start for the time. So how do I say this thing right here? Now, I'm going too fast. I realize that. Okay, now we caught up. How do I say this thing right here in math notation?
Delta y over delta x.
You are 100% correct. That is math notation, and I phrased my question poorly. Delta y over delta x. You are, yeah, great. Is there some way that I can write out what delta y was? If I always choose my end to be the B point and my start to be the A point, so if I come back here, if this is A, let's come label this with green. If this was point A and this is point B, this is time B, time A, so 60 is B, 0 is A. What is this formula here? And this is a review of Algebra 1 still. I'll give us a hint. This starts out by saying f of b. Because the end, in terms of the distance, my distance is my y value. So I have to do f of whatever my endpoint was. So I did f of b. So I'm going to do f of b minus something else.
F of A.
F of a. And then arrow, you can do the bottom. My times, I don't need any f's. Those are just on the x-axis. It's just a and b. So what's the correct?
It's B minus A.
It's b minus a. Perfect. B minus a. Perfect. So this entire time here was easy for us to find because our a was 0. So all we had to do is really look at our b. So just kind of going back through the logic that Ben told us, when we found our average rate, so our example from above, we said that our ending distance, this f of b here, I keep going forward, our ending distance was 50. So this is 50 minus, and then our starting distance was 0. And our ending time was 60, and again, that's coming from this ending time down here. B is 60 minus 0. And that's where this 50 miles per 60 minutes came from. And you can say this one of two ways. You could say that that's 5/6 miles per minute, or more commonly, that is 50 mile per hour. Easy peasy? All right, so just make sure that you always know it's end minus start over end minus start, and that is today's lesson. Go ahead and write your summaries.